In this video, I would like to discuss using z-value to decide whether you should reject or fail to reject the null hypothesis H0. If you have some experience in hypothesis tests, then you might be saying, all right, I studied this in the past, so what I did was I read the problem first, and then I pick up all the givens, so let's say the X bar, the mu, the sample size, the standard deviation, and then I plug all those into my graphing calculator and then press calculate. The calculator will show me the z-value, the t-value, and then the calculator will give me a p-value, right? And the next thing is I have to compare the p-value with alpha. If p-value is less than alpha, then I say we reject the null hypothesis and say the alternative hypothesis is true. Is this correct? The answer is absolutely correct. So everything you said is absolutely right. What I wanted to discuss is what's behind the scene. So what's the concept behind all of this? You said you calculate z, and then the calculator gives you a p-value, and then the p-value is less than alpha, and then you reject H0. So what's the concept behind this? Why do you reject H0 when the p-value is less than alpha? So I am going to discuss all the whys in this video. So first of all, let's go over some vocabulary. We should not go over, we should call that a review. The first one is significance level alpha, that has another name, is called rejection region if we are talking about pictures. What is alpha? Alpha is the maximum allowable probability to reject the null hypothesis, and alpha is usually given in the problem. So for the entire discussion, I would like to let alpha be 0.05. So the first picture you see here is a left-sided test. How do you know the test is left side? Easy. You check out the sign of the alternative hypothesis HA. So HA is mu equals to mu naught. So mu naught, the mu naught is the mean, the population mean that has to be tested. So I am trying to test the mu naught. I'm trying to challenge the mu naught. So that's why we call that mu naught, not mu. So mu naught is a number that we are about to test. And then you have a red region in the bell curve, right? So the red region, take a look at the red region. I said that z is equals to negative 1.65. So what is the red region? The red region is, so let me just do this in red. The red region is the alpha. So this red region is alpha equals to 0.05. So 0.05 is the area of the rejection region. So the red region, do you see there? What's the area? The area is equal to alpha, 0.05. The corresponding z-value is negative 1.645. How do you get that? We use inverse normal distribution. Inverse norm, so when you do inverse norm in your calculator, you press the second, and then you press VARS, 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 and then you find inverse norm, you input the area, followed by the mean 0, and the standard deviation is 1. They are 0 and 1 because this is standard normal. And then you have negative 1.645 in 3 decimal places, so that is the z on the left hand side of the mean. So we have the rejection region, we know the area, and then we know the corresponding z. So what if you get a green z? So what do I mean by green z? Green z, I said that I draw a green arrow and say that is less than negative 1.65. How do you get the green z? So to get the green z, do you still remember the standardization formula? You take x bar minus mu divided by sigma over square root of n. How do you get those four numbers? The x bar, the mu, the sigma, and the n. You read the problem, and then you pick up those four numbers from the problem, and then you plug in those four numbers into the formula. In case you don't remember what it is, I better write it out for you. So we are talking about z. Let's use a different color. We are talking about z equals to x bar minus mu divided by sigma over square root of n. So you read the problem first, you pick up these four numbers, plug it in, you get a z. If that z is less than negative 1.6645, so that means an even more negative number, we reject H0. And then you are going to ask me this question, hey, you just say z less than negative 1.645 and then you reject H0? You are not even in the p-value yet. Right, I am saying that when z is less than negative 1.645, is less than the cutoff of the rejection region, I reject the null hypothesis. The first reason is the green Z is inside the rejection region. So what is rejection region? When I was learning this, I am thinking about rejection region as a red zone, restricted area that is full of bombs. If you step in there, you detonate the bomb, boom, you are gone. So that is what I was thinking when I was learning rejection region. So it's like a red zone. If you step in the rejection region, you reject the null hypothesis. Again, it's like a red zone. If you are in the rejection region, you have to reject the null hypothesis. And then the question you asked was, hey, you are not talking, you are not in the p-value yet. Right, what is the p-value of the green Z? This is the left-sided test. For the green Z, the p-value is from negative infinity all the way to the cutoff. So if you want me to draw the p-value for you, the p-value is there, the green area, from negative infinity all the way to the green cut. So do we agree that the p-value is inside the rejection region? Yes. So that's why you reject H0. Number two, do we agree that the green Z is also inside the rejection region? You reject the H0. Now, the next question is the green region and the red region, which one is bigger? Again, the green region versus the red region, which one is bigger? The red is bigger. So that means the p-value from the green Z is less than the alpha. So that's why we reject the null hypothesis. So that's what goes behind the scene of the stuff that you did using your calculator. You said p-value is less than alpha, we reject the null hypothesis. But why? Here is why. The green Z is inside the rejection region. The green p-value is less than the rejection region. Then you reject the null hypothesis. Okay, so that's how you do how you get the reject the null hypothesis. What about fail to reject? So let's erase the green p-value and then take a look at the blue Z. So the blue Z is outside the rejection region, is greater than 1.6045 anywhere outside the rejection region. It doesn't have to be that spot. It's greater than the outside of the rejection region. So I failed to reject the null hypothesis because I did not step in the rejection region. Then what about the p-value? So the p-value of the blue Z is here. It's from negative infinity all the way to the blue cut. So from negative infinity all the way to the blue cut. The next question is the red region and the blue region. Which one is bigger? Of course, the blue region is bigger. That means the p-value of the blue Z is greater than the rejection region. Therefore, we fail to reject the null hypothesis. So that is for the one-sided test. All right, so let's erase that, and then the next step is let's move on to the right side. So for the right side, if you understand the left side, you understand the right side. So here is the right side. So we have a rejection region. The rejection region, what's the rejection region? So in the entire video, I let alpha be 0.05. So the area of the red region is alpha 0.05. And then we have 2Z, one green, one blue. So the green Z is greater than 1.65 because that is inside the rejection region and that is far off to the right. So the green must be bigger than the red. And then since the green Z is bigger than the red Z, we reject the null hypothesis. But what about using the p-value? So before we do that, let's go over this again. The green Z is greater than the red Z. That's why if you have anything greater than the red Z, you reject the null hypothesis. That is reject H0 using Z. How about reject H0 using p-value? What is the corresponding p-value of the green Z? The p-value is right over here. From the green Z all the way to positive infinity. So since the green region is less than the red region, therefore the p-value is less than alpha, we reject the null hypothesis. So that's for the green. What about for the blue? The blue is outside the rejection region. Therefore, we fail to reject the null hypothesis. So for the green, I better add this. So this green is reject H0. And then the red is fail to reject H0. So fail to reject H0 because the So the red, did I say the red? The blue is outside of the red zone, so that is failed to reject the null hypothesis. What is the corresponding p-value of the red Z? The corresponding p-value is from the blue cut all the way to positive infinity, and it is certainly greater than the rejection region. So that's why if you have a blue Z, the Z is less than it's less than 1.645, and its corresponding p-value is greater than alpha. Therefore, you fail to reject the null hypothesis. So that's for the right-sided test. And then how about the two-sided? The two-sided is not too complicated to interpret. The first thing that you will have to do is you have to divide the p-value into two pieces. Sorry, not the p-value, the rejection region. So it is 0.05 equals to alpha, right? So since the two-sided, you have a not equal, two-sided, the alternative hypothesis, mu is not equal to mu naught, so you have to divide the 0.05 into two pieces. That becomes 0.025. So you have half of alpha on the left side and then half of alpha on the right hand side. So first of all, you have to cut the rejection region into two pieces, half on the left, half on the right. And then since you cut that into two pieces, that reduce the rejection region on each side, then you have to recalculate a Z. So for the inverse norm, do you see that for the inverse norm command, I take the alpha divided by 2. So this time I get another Z, negative 1.960 and a positive 1.960. One on the left, one on the right. The graph is symmetrical. You always get a negative from the calculator because the calculator assumes the area is on the left. Since for the symmetrical property, we have a negative on the left, positive on the right, 0 right in the middle. And then what if you get a green Z? So if you get a green Z, the green Z is inside the rejection region, either less than negative 1.960 or greater than positive 1.960, depending on the problem. So what is the p-value of the green Z? The p-value would be either this side or that side. So that's the p-value of the green C. Oh, sorry. Let me correct myself. What is the p-value of the green C? So on the right-hand side, let me fix that Z is not equal to 1.960. Z is greater than 1.960. So that's how you go to the right. And then what is the p-value? The p-value is the sum of those two regions, of the two green regions. So if you get a Z either less than negative 1.960 or greater than positive 1.960, what is the p-value of that test? The p-value is the sum of the two green region. So since they are both inside the rejection region, that means the p-value is less than alpha. Therefore, we reject the null hypothesis. So make this clear. Z inside the rejection region, you reject the null hypothesis. Its corresponding p-value is also less than the rejection region, you reject the null hypothesis. So what about the blue Z? So the blue Z, the one on the left is greater than negative 1.960. The one on the right is less than negative 1.960. So what is the corresponding p-value? The corresponding p-value is the entire blue piece on the left plus the entire blue piece on the right. And that is definitely greater than the p-value, the red zone. So therefore, you fail to reject the null hypothesis. All right, so that is the end of this video. If you think my instruction is clear and helpful, give me a like, subscribe to my channel, share the video for me. Appreciate for your help and support. See you all in the next one. Signing out for now.